Hi and welcome to the lesson about streaming and idempotency. So in this lesson it will be a little bit different because it's still a demo, but I will not show you a lot of code. Instead I will show you different how to leverage data stores, typically here Apache Kafka, to implement the idempotency with the built-in features. And to start, I will show you the Apache Kafka compaction. So compaction is a process that removes duplicated events for the given key in Apache Kafka. And to enable it, you will have to create a topic with the appropriate cleanup policy and of course all the retention. So for me it's a quite aggressive config to show you that in action, but generally it will depend on your business use case. Maybe sometimes it's good to keep these duplicates, maybe sometimes it's not. It's up to you to choose what approach to use. So I will go now to my Docker directory. Okay, it's Kafka only, and it's as the name indicates, it's only an Apache Kafka with Zookeeper. So I will start the Kafka broker right now and create a new topic with this quite aggressive compaction. So it's already started. Yes, not yet. Okay, I have to wait a few minutes. Unless the Docker Kafka one, yes, it's not the good command. Sorry for that. I will just fix it here. Okay, you can see that the topic has been created. So now I will also open a new consumer for that topic. And a new data generator. And in this data generator, as you can see, I will put some key value records. And the goal is to see what will be the last record kept by the consumer after the compaction. So I will go pretty quickly here, one by one. So the consumer, as you can see, it consumed all the records because it was up and running, and the compaction hasn't run yet. But what happens if we reopen the consumer and we reprocess exactly the same topic from the beginning? And as you can see here, the compaction took place because we have only 2 rows for the key number 1, whereas previously we had 4 rows for the same key. So that's the first way to ensure the idempotency, meaning that the one entry per key, even though the value is different. The value can be different, by the way, if you, for example, reprocess the data for from a buggy pipeline. You fix the error and you deploy and you reprocess the data. Yes, in that case, the value will be very probably different. And that was for the compaction. So I will now stop the demo and stop the Kafka broker. And I will go to the Kafka with confluent distribution, which is a little bit different. So let me maybe just show you that before. Okay, I'm already in this. Yes, so the Docker has much more components. There is Kafka broker, of course, but there is also schema registry and Kafka connect that I will use to demonstrate the idempotency for the second part of the demo. So I will now start the components, and yes, you can see that they all started. And for me now, the goal will be to create a new topic called raw data. I will maybe try to do it with one partition for the sake of simplicity. Okay, the topic is there. So now I will register a new Kafka connector. Kafka connector, which is an application that consumes Apache Kafka topic and writes the data to a different data store. And for me, this data store will be an HDFS distributed file system. So there is a different configuration like converters, like of course the configuration for the input and the output, flash size, and partition format, but I will show you that later when we have some data written. So just check if the container is running, and we can see that it's correctly configured and running. So now I will open HDFS and list the first directory of with the topics, and you can see there is nothing here because I have no data written to my raw data topic. And I will try to change it right now. So I will quickly copy new records from my demo instructions. It's quite important to not add any new line because it can break the synchronization. And of course, now we can check again the topics. You can see that we have already something new with raw data. And if we check the raw data, you can see that we start having our partition scheme that corresponds to the event time of the record. So we have the month, which is the August, and typically the day that will be the 11th. And you can see that we have even an hour, so I completely forgotten that part. And now we should see the first files. Yes, you can see that the files are synchronized, and an interesting pattern for that is this synchronization offset. So for example, in Apache Kafka, each record has an assigned position offset, and this position is a part of the written file. So here we have a naming scheme composed of the topic name or the number of partition, the first and the last offset present in the given file, so that even though you reprocess the data, you shouldn't create a new file, you should only overwrite it. And let me show you that right now. I will delete my synchronizer. I will add the connector again. So here, if I do the listing, you should see that the file hasn't changed since the last data generation. So it's not overwritten, but if we add another connector, writing data to a different place, and this different place is configured here in the topics dir property, you should see that the new data will be generated. So we have raw data only so far, and soon we should get, oh yes, it's not topics, it's topics too, by the way. And yes, you can see that we have the raw data, and we should have the same schema for the partition as for the previous run, for the previous container. So Kafka Connect is a great example of enhancing, of using metadata to ensure the idempotency, because these offsets are part of the metadata related to each event, each record stored in the topic. And finally, so I will stop all these containers. I will go back to the Kafka only, start them again, and show you the demo of an idempotent data producer. Okay, I just started the consumer, my broker is up and running, and now I will go to my idempotent producer and do some tricky actions, which consist of adding the breakpoint. So I will add the breakpoints to the transaction manager class. So unfortunately, the single way I found to demonstrate this this feature, and you can see that the breakpoint is just here. And exceptional, this time I will introduce some basics with the picture. So the idea of the idempotency producer consists of these actions. So I have the producer, Kafka library assigns a producer ID, and later the producer sends the record alongside its ID and the last sequence number the producer has. So for the first record, it's quite fine. The broker gets these two information, compare with the sequence number that it's stored locally, and if it's okay, if it's strictly increasing, the sequence number is strictly increasing, the record is added and the producer can update the sequence number. So here you can see that the flow is also okay, but what happens if the broker doesn't succeed to notify the producer? If it happens, the producer will try to resend this record number 2 with the previous sequence number, so 1. And the producer doesn't know that the broker already has this record assigned to the sequence number because the producer didn't get the outcome, the confirmation, because of this temporary network failure. And that's the reason of the retry, and that's the reason why there won't be another record written to the Kafka broker. Instead, the Kafka broker will send an out of sequence exception, and the producer will restart the generation. And now I will show you this kind of network partition network problem with the debug I have just added before. So to demonstrate this error, I added the breakpoint here, and after a few runs I will change the value of the nest sequence number to be lower than the last acknowledged number, meaning that it will simulate a kind of partition failure. And I will also start the consumer from the beginning of the topic existence to show you that at some point we will have some missing record. So we have the record number 7 already. Let's check the sequences. Topic partition, you can see that the next sequence for the producer is 8, but the last acknowledged sequence on the a broker is 5. So I will put this value to something lower than 5, like 3. And here we should have now some out of order sequence errors and missing deliveries of the consumers on the consumer side. So we have out of order sequence number many times. And what happens later? So what happens later is that we have our values on the consumer 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But since we artificially simulated the partition error, the network partition error, sorry, the producer didn't send, or more exactly, the producer did send the records, but the broker didn't acknowledge, didn't write them, simply because the sequence number was not the one it expected. So it expected, remember, the sequence number 5 or more, but the producer associated the sequence number to these values 10 and 11 with less, so with 3 and 4 to be more exact. And after that, we can see that the producer recovered from this temporary error and continued to send the records. And we can also probably find the out of sequence error somewhere in this. Yes, you can see exactly the error I have been talking about just a minute ago. We have this failed delivery for these two records, the message that the broker received out of order sequence number, and also here that the message that producer is recovering for this delivery by resetting the sequence number for the batch. So that was this third example. So remember, you can do the idempotency different ways. You can do it either by leveraging the data store like we have done before with Apache Kafka compaction that automatically removes the duplicated keys, events with duplicated keys from the topic, from the partition. Second part is about built-in tools that rely on the metadata to ensure the idempotency, as it was the case of the Kafka Connect. And thirdly, there is also some mechanism that you might have on the database side that communicates with the data producers, typically here with these sequence numbers that must be always synchronized between producer and the broker. Otherwise, the broker will consider the data as out of order, so probably already delivered, and it avoids, of course, adding some duplicates. Thanks for watching and see you in the next lesson.